My name is Michelle Bottomley from Tetherdown Primary School, and this is my lesson on algebra. We need an input number. Could we have a single digit input to begin with? Jerry?
5.
We're going to activate our function machine, and something is going to happen to our number. The output is 0.5. Could you write on your whiteboards what you think might have happened in our function machine? So I start the lesson using a function machine because I think it's helpful for the children to understand that we're looking for a rule. Now that work on function machines is going to become useful a little bit later. You might see why as the lesson progresses. So once we've looked at the function machine and set up that idea and move on to the main part of the lesson, which is considering the problem with the chessboard. Who can remind me and the rest of the class what we did?
We had to find out how many squares there were in the chessboard, including squares made from 4, 9 and all of the different ones.
Ultimately, I wanted the children to discover if a chessboard was made that was 25 squares in length, how many squares they would find. We're going to start by looking at how many squares are in a chessboard with 1 square, 4 squares, 9 squares, and then go on to 16 squares. But we're not, you'll be pleased to hear, going to do that all the way up to 25. What do you think we're going to work out along the way?
Well, you might be able to find a pattern once you're starting it. So after about 8 by 8, you might start to find a pattern, and then that could help you.
Excellent, well done. We're going to be looking for patterns to help us work it out so we don't have to go all the way down to 25. You will need the sheet that looks like this, where you're going to record some of the information, and the table, because we need to tabulate the information in order to work systematically.
10, 11, 12, 13, Toby, and then one extra one for that. So that's 14.
So we started with the 1 by 1, now we're doing the 2 by 2.
There's 4.
4 of those. Can you mark that down? Excellent, Alice. Well done.
And then there's the one big 3 by 3.
Good. And if you could record that. Thank you very much, Alice.
14.
What do you notice, anybody, about the numbers that Alice has recorded?
Are they all square numbers?
Well done, Ruben. And that is going to help us solve this puzzle. So I produced the table for them so that their main focus was to collect the data for the lesson, and as they were collecting the data, to start to look for the patterns that they were seeing.
There's 4, so it's 4 by 4. Yeah, but now look, 16. I know, but now look at this. Right, there's 9 for 1, then there's 16, 9, 4. So I think it'll be 25, 16, and 9.
The square numbers on 1, you have to add on the square number, which is 4, to make 5. And then you have to add on 9 to make 14. And then you have to add on 16 to make 30. So we're just adding the square numbers to the numbers in the.
Okay, well done. You've spotted the pattern. Now what we want to move on to, and I'll move the rest of the class in a moment onto, is looking for a formula. So if I said to you tomorrow, actually, they've invented a chessboard that's 125 by 125 squares, you don't have to add all these square numbers up. I think it will be very unlikely that Year 6 pupils will get to the final formula, but they will be able to use the formula at the end of the lesson in order to check back their own results. And also they'll be able to see that it can be done, which I think is quite important. What you've got to do with investigations like this is imagine, just like our function machine, you're putting some numbers into the function machine, something happens to them, like it did at the beginning of the lesson, and then another number comes out. And for the data in our table, that is happening. You're putting the number 1 in, the length of one side, and then out comes 1. You put 2 in, out comes 5. You put 3 in, and out comes 14. And the same thing is happening to those numbers each time. And what we need to work out, we're going to ignore this column, ignore the middle column, and try and work out what is happening, what function, what operation is going on in our machine. Well, for me, what's great about this lesson is that everybody can take part. If you're doing a very sort of focused and narrow lesson about a particular element of number, for example, then it's very difficult to reach everybody. But I think with an investigation, there's always something for everybody, and particularly this one. So my less able pupils perhaps will have a better understanding of square numbers by the end of it. My more able pupils will start to look for that formula and look for the rule and understand formal algebra a little bit better.